Good morning or good afternoon for you, and welcome to our webinar, Why Service-Oriented Monitoring is the Future. And today we will learn all about monitoring across value streams under the guidance of our experts. I am Jimena, member of the marketing team, and I'll be your host for today. Throughout the presentation, I'll show you the results of some interesting polls that we've conducted. And now I'll leave you in the capable hands of today's speakers, Stephen and David.
Hi, my name is Stephen Hopkinson. I'm one of the senior systems engineers here at Paessler working on the pre-sales team. I'm based in the UK and I've been with the company for 6 years.
Hi, I'm David Montoya. I'm Business Development Manager for OT and IoT, and I've been with the company for 9 years, and today I'll talk about the particularity of industrial Ethernet networks.
So let's take a look at our agenda for today. So we're going to give a brief introduction to Paessler. We're then going to talk about why monitoring is important. We'll then jump into a different way at looking at our monitoring using a service-orientated approach. We'll then talk about how this can be done via PRTG, and we will end with a quick Q&A. So a quick introduction to Paessler. We are the monitoring experts, founded by Dirk Paessler in 1997 in the city of Nuremberg in Germany. We are a global company that's been around for over 25 years now, and PRTG itself was created in 2003. So we've been in the monitoring space a long time. So let's take a look now at why monitoring is important. Well, in today's world, everything is connected. So this could be your IT space, it could be your OT space, it could be your on-premise, it could be your cloud space, it could be third-party services and applications. And because of this, we have many, many systems with many, many screens and applications that we need to take a look at. Now, you could be the admin on the left, that has to look through many of these applications to keep an eye on everything. Or if you found PRTG, you can be the admin on the right and have a single pane of glass view of the health of all of your systems. So there are 4 components to monitoring. First, we must measure those metrics regarding the availability and performance of your key systems and devices. We then wish to be informed and alerted to any critical issues. We can also take that monitoring information and analyze it for the purpose of optimizing your own environment so that we can save on cost and time. Now, when we talk about monitoring, we're not just talking about the IT space anymore. We have many different silos that build into your business services. So this could be your traditional IT in your data center or in your cloud space, but it could also be your OT environment within your factory floor or on the shop floor. It could be your IIoT space or your IoT space. So we want to start looking at monitoring from a different perspective. And we do this by taking a look at a service-oriented approach where we consider the business processes and what components form part of that service, and then we monitor each of those components. And we can start this process through value stream mapping. So value stream mapping is where we take the particular components that form part of a product and a service, and we group them together under a service view. Now in IT, if we know which elements are involved, we can monitor those, but we can also monitor elements outside of the traditional IT space within the OT, IoT, or IoT space. Now, a good way to look at the different elements within your infrastructure is through the OSI model. The OSI model is a conceptual model that details the flow of information through your network. Typically, a request for information will start at the application layer. It will move down the layers until it reaches the physical layer, and then back up through the layers until it reaches its destination. Now, before we take a quick look at those layers in more detail, let's stop for a quick poll.
Yes, thank you, Stephen. So we want to share this with you because we asked some of our customers, which infrastructure layers are you currently monitoring? And you can see here some of the interesting results. 67%, for example, mentioned that the network layer followed by the application layer are the ones that they monitor most. And then we have the physical layer with 37%. 21% said that they are monitoring all of them, and only 10% that they are not sure. And now back to you, Stephen.
Thank you. So let's start at the physical layer, layer 1 of the OSI model. And we're going to talk about the different examples, use cases, and sensors that we can use to monitor this layer, both from an IT perspective and an OT perspective. So from the IT perspective, the types of devices that we might monitor at this layer include the network switches and servers, disks, power supplies, fans, UPSs, and any other physical hardware within your infrastructure. So a particular use case could be to monitor the physical health of your devices, taking metrics such as temperature, power, usage, fan status to prevent failures of those hardware elements. And we have a number of sensors that can cover this. Some of those include the S&MP hardware status sensor. So this monitors devices for things such as fan speed, temperature, and power. We also have a special sensor called our Redfish sensor, which uses the Redfish protocol. And Redfish is supported by many servers out there. So if it does support Redfish, you can use our Redfish sensor to monitor many of those hardware metrics. Likewise, our IPMI sensor monitors any devices that support the IPMI protocol. So if you want to monitor an iDRAC or an ILO or some other similar piece of hardware, then we can do this via IPMI. We also have vendor-specific sensors for things such as our UPSs. So for instance, here we have an APS UPS sensor, which tracks the UPS load battery status and input/output voltage for that device. So David, how does that look from the OT space?
Thanks, Stephen. From the OT space, we have some subtle differences. So what we can expect to find on the physical layer are things like industrial control devices. These are PLCs, which for those who don't know the acronym, it stands for Programmable Logic Controllers. We might have RTUs, which are remote terminal units. We might have, of course, industrial switches, and also the sensors and actuators, which are actually the devices which do the automation when we're talking about industrial automation networks. So in this case, for the physical layer, our use case is to make sure that those devices like the PLCs, the RTUs, sensors, and actuators are physically connected to the network and that they are powered and running, right? So in this case, we also have some examples of useful sensors that we have within PRTG, like the ping sensor, which is going to tell you whether those PLCs and RTUs are reachable in the networks. And this might be very important because we might think of, a PLC running on a factory floor, for instance. But if the PLC is running on a mine, the fact that it disconnects can actually have, or it can create issues in terms of safety, for instance, for the workers in the mine. So in the PLC world, this is very important to make sure that they are available at all times. We also have some S&MP sensors to support with the network interfaces of the industrial switches or other devices like field controllers as well. And for one of the most important sensors for us in terms of industrial gear is the Modbus TCP sensor. So this can help us to monitor health status through the memory registers of the controllers or the different types of devices, so that you can keep track of what's going on, similarly to what you could do with S&MP, for instance. Over to you, Steve. Oh, sorry. You're right. For those who don't know the PLC monitoring, right, this is how a PLC looks like, right? And there are some examples here of the OPC UA custom Modbus, S&MP, and MQTT sensors that we would like to show. So this is the way how you could expect to have your dashboards in terms of sensors, right? You can see they're very similar. Look and feel is exactly the same as a CPU or SNMP traffic. And yeah, this is good for all of those who haven't seen information on the industrial protocols that we support with PRTG. With RTUs, it looks pretty much the same. So an RTU is a different type of hardware, but you can expect to see the same kind of detail to the RTU. So in this case, detect operational disruptions, increase security, improve network and process stability, optimize energy efficiency, reduce maintenance efforts. So all of this is what you can expect to find from the physical layer in an industrial network. And now over to you, Steve.
Thank you, David. Okay, so let's move up a layer now and talk about the data link layer. So again, examples of devices that we might monitor at this layer include your managed layer 2 switches, your network interface cards, your NICs, and your wireless access points. So a use case for this could be to monitor port traffic for errors, as well as VLAN performance to maintain efficient data transmission across your network. And again, we have some very specific sensors that allow us to do this. So one such sensor is our SNMP traffic sensor. And this sensor does exactly what it says. It monitors the bandwidth usage on a particular switch or router interface. We also have our Windows network card sensor. So this checks the local NIC traffic on a particular Windows system. And we have our SNMP Arbon sensor, which can provide additional statistics such as errors and collisions. And we also have a very special sensor, one of our custom sensors, the SSH script or the SSH script advanced sensor, which can monitor any custom metric that can be returned via SSH. So as long as you can return a metric via an SSH script in a numeric format, we can monitor it in PRTG. So David, how does that look in the OT space?
It actually looks very similar. So you can also expect to find industrial Ethernet switches, devices that use proprietary communication protocols, which is what might differ from a regular IT network, things like Profibus or EtherCAT, right? And the use case in this case for us is checking the quality of the Ethernet communication or the use of protocols which are native to industrial machines. So our examples for usable sensors are the packet sniffer sensors, which are going to help you monitor communications performance on industrial Ethernet networks, such as the usage of specific types of traffics like EtherCAT, and also the SNMP traffic sensor that most of you probably know already, which helps us to monitor the throughput on the industrial switches in this case. So for us to see how good it looked like, just a little screenshot of our packet sniffer sensor, and then perhaps just a collection of little sensors in terms of monitoring the industrial data link layer in industrial networks. And Steve, can you tell us something about the network layer?
I can. So moving up a layer now to that third layer, the network layer. And this is the layer that you might traditionally look at when monitoring the network space. And some examples of devices in the network layer, of course, include your routers and your managed layer 3 switches, as well as your firewalls. And a use case for monitoring this layer could be to check for connectivity, IP routing, and latency between those networks. Again, we have some additional sensors that we can show you today. First, let's start with our most basic sensor, the ping sensor, and this can track basic uptime and latency. We also have a traceroute hop count sensor. So this is useful for monitoring particular hop counts between a source and a destination along the routing path. And we also have our, again, one of our vendor-specific sensors, the Cisco ASA VPN traffic sensor, which monitors the encrypted traffic over a routed path using the Cisco devices. How does this look in the OT space, David?
Well, for the OT space, you can find industrial routers, of course, and a lot of gateways devices, between the IT and the OT networks, because there is the push for having more information flowing between this type of networks for decision-making processes for machine learning topics, etc. So there are a bunch of gateway devices which are providing secure information flowing through the networks. So in this case, monitoring IP communications between the industrial devices and IT systems, and also across multiple VLANs within the industrial networks. So for this example, what we have are the ping sensors to monitor the availability of those devices and the gateways, the SNMP sensors, which can support in monitoring the OT VLANs that are likely happening in the industrial space, and also port sensors, which can support us to monitor connectivity between industrial and networking devices through those ports which are being used natively by the industrial protocols. In this case, the next topic is how does HMI monitoring, SCADA monitoring looks like. We are trying to ensure system availability at all times. For those who are not familiar, the SCADA system is an application, but the HMI devices are screens which are connected physically to the controllers so that people in the shop floor might be looking at the screen and knowing what's going on. But those HMIs, they offer individual views of what's going on with the specific controller. So whenever you are trying to consolidate those views, it makes sense for you to use PRTG for that. We are trying to ensure system availability, as we said, with early detection of failures and malfunctions, monitoring the performance of these devices, because they as well use CPU and RAM, and they create network traffic and receive network traffic. So we want to make sure that all those metrics are under control. They minimize the errors and the security risks. As we have said, security is one of the main topics when it comes to OT networks, just because of the lack of security in some cases, which actually makes those networks to be air-gapped for ensuring that there are not going to be a lot of issues. But with this interconnection, the IT and OT convergence, we need to make sure that security is a big topic when we're talking about monitoring as well. Proactive maintenance prevents production downtime and improves operations. We really want to support our customers to prevent the production downtime because we know how costly it is. And then the IT-OT integration. So optimization, communication between the SCADAs, the HMIs, the other systems. So here we have some examples for those who are not familiar with an HMI. That's how it looks like. And I guess we're good to go to know more about the transport layer. What can you tell us about it, Stephen?
Thank you, David. Okay, so at this layer, we're looking at devices in the IT space that include firewalls, load balancers, and application delivery controllers. And the use case for this is to monitor things such as the TCP/UDP port availability and performance, and to track any dropped connections. And again, we have a set of sensors that are very good for this. The first of those being the port sensor. So the port sensor can check whether a TCP port, or indeed any port on a device, is open and how fast it responds. We also have our NetFlow sensor, which is available for both version 5 and version 9. And this can monitor the traffic flow across a device via the transport layer. And it can monitor things such as source and destination information, as well as the ports. So we can look for things such as bottlenecks. We also have a packet sniffer sensor, which is very similar to the NetFlow sensor. And this again captures traffic by its protocol for any TCP or UDP port to analyze throughput. And finally, we have our quality of service round trip sensor, which monitors latency, jitter, and packet loss. Over to you, David.
Thank you. So for the transport layer on an industrial network, we also have industrial firewalls. We also use VPNs, and we have, again, our good friends, the controllers. So in this case, similarly to the IT networks, what we are trying to do is to ensure communication between the OT devices, like our controllers, over industrial protocols. One of the most useful examples of sensors that we have for this is the Modbus TCP custom sensor. So this is monitoring the Modbus communication between OT devices using the TCP protocol. We have a different flavor of that sensor as well within PRTG. That's the Modbus RTU, which can support non-Ethernet connections when they are eventually connected to an Ethernet device like a laptop, for instance. So this Modbus TCP is a very cool sensor that we have available. And we also have the Python script advanced sensor. Why do I mention this? Because there are some other protocols that we do not natively support at this time with PRTG, but we have created some scripts to support in that. One of these is called Ethernet IP. It's one of the most useful protocols when it comes to controllers created by Alan Bradley in the US. So we have some libraries to review accessibility of that protocol too. And what we would like to show is how this Modbus TCP custom sensor looks like. In this case, what we're showing here is Modbus TCP querying information from an energy meter, right? So in this case, we're measuring the energy usage of motors or any other connected machines. This could also be critical power devices such as battery banks, or it could be an emergency generator or something of the sort. The important metrics in this case are, of course, the voltages, the current, amperage, the power consumption. Power consumption is something that we all can relate to, because what we are trying to do is make our operations more efficient and also reduce the consumption of energy that we have for us to operate. So what we are doing here is data logging from those controllers all over to PRTG, right? And this can also support in those cases where you would not like to pay for a highly expensive data historian, but you would like to keep historical track of the metrics that you are creating with your controller. So this helps us optimize energy usage, reducing the cost, and also identifying inefficiencies in our example in motor operations, but in other examples, it can be anything that you are using in terms of energy as well. And over to you, Stephen.
Thanks, David. So moving up another layer, we're now going to look at the session layer. So the session layer, as per the name suggests, look at anything that handles sessions. So for devices that are monitored in this space, this could be your VPNs, your virtual private networks. It could be your authentication servers, such as Radius, and even your VoIP systems. So a use case for this is to monitor the active user sessions, for instance, via VPN, session durations, and login performance. And again, we have some sensors that cover this for us. So looking back again now at the SNMP Cisco ASA VPN connection sensor, we can see that some of our sensors do monitor across the layers, and this sensor can track the number of active VPN sessions for us. We also have another one of our custom sensors, which is the XE script sensor, or the XE script advanced sensor. And we can use this with a custom script to query how many users are currently logged into the OS. And again, this sensor can be used to monitor any numeric value that we can pull via a script through PRTG. We also have a specific sensor for Radius. So this authenticates via Radius and measures the response time. And for the Windows space, we have our WMI terminal services sensor. So this monitors the remote desktop sessions on a Windows server. So how does this look from the OT space, David?
Well, in the OT space, what we have are the PLCs that we have continuously been talking about. We have the HMIs, but we also have engineering workstations. All of these work through sessions. So the use case, similarly to the IT space, is to track the active sessions in these HMI systems, the SCADA servers, and especially ensuring that there is no unauthorized access or disruptions, right? So in our example for OT, what we have is the XE script sensor, which, as you mentioned, Stephen, is querying how many users are logged into the OS, sorry. And then we have a particular sensor when we are using the OPC UA infrastructure. The OPC UA infrastructure is a client-server infrastructure that will allow us to keep our communications, industrial communications safe. And therefore, we have an OPC UA server status sensor for that. It's going to track the status of the OPC servers, which are exchanging data with SCADA systems or any other types of industrial control systems. And the way these sensors look like is like this. This is a out-of-the-box sensor that people can use when you are using OPC UA servers already. And then we're going to query that server, and as part of the channels that you can see in the sensor, we will keep track of all the sessions tied to that server. So we're trying to support you to keep your operations safe on the OT space as well. And I believe we can move over to the presentation layer, Stephen.
Thanks, David. So at this layer, we're looking at monitoring things such as our web application servers, our load balancers, and anything that uses SSL for encryption. Now, a use case for this might be to ensure that data encryption or decryption and compression are operating correctly, and that we're monitoring the health of our certificates. And some of the sensors that we use for this include some of my favorite sensors. The first of these, of course, is the SSL certificate sensor. So this monitors the certificate validity and expiration. So no longer any need to monitor your SSL certificates via a spreadsheet. You can simply apply this sensor to any device or application that requires an SSL certificate in PRTG, and PRTG will alert you when this sensor is due for renewal. We also have the SSL security check sensor, and again, this validates the SSL or TLS versions, ciphers, and vulnerabilities that are supported on a particular device or application, and can alert you to any weak protocols that are still supported. We also have the HTTP advanced sensor. So this monitors headers within a HTTP packet and redirects an SSL sessions. We also have the HTTP full web page sensor, and this monitors the full load time of a particular page, which can be used to monitor the health of a particular website. Finally, we have our WMI file sensor, and this can be used to track the encoding or conversion via file monitoring. So what does this look like in the OT space?
Well, in the OT space, presentation starts becoming closer and closer to IT type of application. So in our example, we have a SCADA system, we have an HMI system. The SCADA could also be an industrial control system of any other sort. And all these are meant to present data in user-friendly formats, right? Machine data specifically. So what we're trying to do here is ensuring that data presentation is in the proper format on the OT devices or the SCADA system. For this, I will talk about the other two types of native OPC UA sensors that we have. We already reviewed the server status, but here we have the OPC UA certificate sensor. So similarly to the SSL certificates that Stephen has already mentioned, here we are going to ensure that the data transferred between the industrial control systems and the devices are presented in a secure format. It's also going to look into expiration of certificates, and you will also get alerts whenever you're getting closer to those expirations. And then probably one of the most usable sensors, because this is customized. We have the OPC UA custom sensor, and this is going to support you monitoring health status alerts on the HMIs to provide a centralized view of multiple little screens to people which is not, in the shop floor at all times, but would like to see an overall status of everything that is going on in the operations. So how does it look like? We have the OPC UA certificate sensor, very similar to the SSL certificate, days to expiration, the public key length, and whether the certificate is self-signed or not. So here again, you have the possibility to not lose secured connectivity because of forgetting that your certificate was about to expire. And the most usable one, especially when we're trying to get information logged from the machines into PRTG, is our OPC UA custom sensor. So the custom sensor also relies on OPC UA. It allows for you to get up to 10 numeric values returned by specific node IDs. As you can see here, the type of information that we're displaying in the sensor is operational information, right? So data logging from the machine so that you can keep track, historical track, and also set alerts and thresholds to conveyor speed or conveyor belt speeds, right? Voltages, power consumption, counters in the production lines, for instance, for defective pieces, etc. So here we are gathering information from your control layer and then being able to keep historical track of that. And you can also use it for alerts and for dashboards. So very interesting things that not everyone's aware of when it comes to PRTG. And what can you tell us about the application layer, Stephen?
Thanks, David. So now at the application layer, which is the final layer of the OSI model, we're looking at that layer in which the user interacts the most. And this is things such as web servers, database servers, and email. So a particular use case for this might be to monitor the availability of particular services or processes. We might wish to monitor application response time or transaction performance. And again, we have some specific sensors that help us with this. The first of those is our Windows IIS application sensor, which monitors Windows IIS via the WMI protocol. We also have our Microsoft SQL v2 sensor, and this monitors a Microsoft SQL database via a SQL query for performance and availability. And indeed, we have similar custom SQL sensors for all of the top databases out there on the market. We also have a number of sensors across our IMAP, SMTP, and POP3, which tests email services for availability and login success via those respective protocols. And finally, another one of our custom sensors, the REST custom sensor, can return any metric to PRTG via a RESTful API that presents that data to us in JSON or XML format. So again, any numeric value that we can pull via an API, we can do so using the REST custom sensor. And in today's age, most applications out there will have some form of API. So this is just another alternative way of monitoring at this layer. How does it look for you, David?
Thank you. So the application layer in an industrial network has to do with industrial control systems or SCADA systems or manufacturing execution systems or data historians, which are all applications, right? So we are also connected to a lot of different servers and industrial PCs in order for us to be able to, make sure that this type of applications are up and running. So the use case here is monitor the infrastructure, which is supporting these applications, the databases, the connections. For this, we have WMI service sensors monitoring WMI services, right? Windows services running those applications. We can also monitor processes using SSH if your application is Unix or Linux based. As Stephen mentioned, REST custom sensors to monitor REST APIs used by a bunch of different modern applications, and especially when we're talking about monitoring OT devices and then exchanging information with IT networks, APIs are quite a big deal. We also have databases, of course, connected to the application. So all the flavors of SQL sensors that we have available in PRTG. What's important here is for you to understand that most of the times industrial control systems, they are not monitoring either the switches or the servers in this particular layer. And we have seen cases where the production needed to stop because of simple, I will call them simple because they are when we're talking about the IT perspective, but simple issues like having a disk getting full, right? And the issue is if you do not try and bridge the gap between IT and OT, might be the case that you're having issues with a disk getting full, and then no one realizes that because everyone's trying to look into this application layer, which is focused solely on everything related to operations. So by the time you reach out to the IT people, and then you are able to figure out that this was a simple topic that could be addressed very quickly, probably some hours have gone by, and those hours are downtime that most of our customers wouldn't like to afford, right? So it's important for us to keep track of this application layer and everything related to servers. And why not also looking into the traffic created by these applications and these servers? So what we have here, just for you to know, is an industrial PC, similar type of use cases as a regular PC. It's just a different format, right? But in the end, what we are trying to look at here is making sure that all communications which are operated, in this case, by servers or PCs, whether they are industrial or regular PCs, are under control. So over to you, Stephen.
Thank you, David. Now, that covers all layers of the traditional OSI model, but there is an additional layer that was added to this model, and this is layer 8, the user layer. And we can actually further split this up into 3 sublayers, which could be layer 8, the individual layer, layer 9, the organizational layer, and layer 10, the governmental layer. Okay, and the purpose of this layer is to understand that while the other layers deal with things, this layer deals with individuals. So this is the user layer. So up until now, we've looked at all of the different components that we may monitor that are physical things or applications, but how do we monitor the users themselves? So how do we monitor the users for any errors that are made at that user level? And when we start thinking about monitoring in this way, then we're really talking about monitoring in a service-orientated way. And we have a very useful blog article that covers monitoring at layer 8 and a lot more information, and there's a link to that in the slide. So the starting point for this, of course, is to monitor across those different value streams. And we've looked using the OSI model at what components make up those different value streams in both the IT and the OT space. But before we look a little bit closer at that layer 8, that user layer, let's go back to Jimena for another poll.
Yes, thank you, Stephen. So in this poll, we also asked to the same group of customers, which layers of the OSI model are you interested in monitoring? And we want to show you the results. In the first place, 52% mentioned that they would like to monitor all of the layers. 30% are interested in monitoring the application layer, and 23% the network layer. Only 6% were unsure about which layers they would like to monitor. We hope you find the results interesting as we do. And now, please, Stephen, you can continue.
Thank you. So when we look at the user layer, we're no longer looking at monitoring things, but we're looking at monitoring what people do. So when we look at this layer from an environment in which employees may work, we may want to look at things such as, are the employees productive? Are they performant? Are they operating in a secure way? Is there productivity apps that can help us do this? Is there other information that we can monitor? In an education environment, in a similar way, we might look at how our students and teachers are performing. Again, are the systems secure? Are they available? Are there specific learning platforms that we need to monitor? Are there other elements within the education space that we may need to keep an eye on?
And what about the healthcare space, right? It's very similar. We need to make sure to let the physicians to focus on people while they are delivering systems and supporting them, right? So if you are an IT person working in a hospital, you want to make sure that you are providing with all the services they need. In this instance, you might want to monitor the transfer data between systems, the bandwidth, the hardware that there is to optimize processes. And this time, and this is why this becomes a little bit more OT, we can still go further, right? So beyond performance and availability of the IT systems, we also provide with HL7 and DICOM sensors that can support for you to monitor your medical infrastructure, your radiology infrastructure, and the systems which are supporting the communications between hospital systems in the end. So that's another alternative we provide.
And in an e-commerce environment, there are many different silos as well that we may wish to monitor to ensure a good customer satisfaction. So this includes the web store, but also the ERP system behind it and any messaging platforms. We may also need to monitor all of the services at the headquarters, as well as all of the infrastructure within our various production sites and warehouses.
And our last case or use case is a production environment. So here we need to keep production lines running. We have heard of this all throughout the webinar, but sometimes we forget how converged the IT and the OT worlds are. So things can go wrong with machines that might be down because of a network issue, but only if we have eyes on all of it and we can respond to these potential outages and threats is where we can become more effective. So monitoring across the tech and the business silos with a unified view is our proposal for all of you. Monitor your IT, your OT in a converged way because the world is making them more converged every time.
So now that we've identified the different silos that might make up a business service or process that we want to monitor, and we've identified using the OSI model which components form those silos, how do we go about this? Well, this is possible using PRTG. So put simply, PRTG is an all-inclusive monitoring platform that allows you to monitor everything across the IT, OT, IoT, and IIoT space. And we can see some of those applications, devices, and services that we can monitor here. So PRTG is not limited just to your traditional IT infrastructure. We go well beyond that into both the extended IT space as well as the OT, IoT, and IoT space. There's things on here that you might not traditionally think of monitoring, such as your CCTV systems and access control systems. But with PRTG, you can absolutely do that. And we do that using PRTG, of which there are 3 flavors. So PRTG Network Monitor is our classic on-premise edition of PRTG. This is self-hosted and allows you to monitor up to 10,000 sensors from a single PRTG core server. We also have the PRTG hosted monitor solution. In this case, we host the core server for you. And again, you can monitor up to 10,000 sensors and you use remote probes for your private network spaces. And for those large-scale customers that require monitoring of more than 10,000 sensors or aspects, we have our PRTG Enterprise Monitor solution. With PRTG Enterprise Monitor, you can deploy as many PRTG core servers as you wish to cover your entire environment. So here we're looking at a traditional architecture of a PRTG installation. So in the corporate LAN, you can see on the left, we have the PRTG core server. And on the PRTG core server, we have the local probe that is responsible for monitoring all of the devices and applications within that local network space. And to monitor other parts of our environment outside of the local network space, we use remote probes. We have 2 types of remote probe. We have our classic remote probe, which is a Windows application, just like the PRTG core server. And we also have our multi-platform probe, which can be deployed on any Linux device. We've also containerized our multi-platform probe now as well. So for any of those enterprise-grade devices that support application hosting, we can now deploy the multi-platform probe. So one of the very special features of PRTG is our maps. Maps are dashboards which are created using a simple drag and drop editor. And this allows us to have a single pane of glass view of all of our monitoring information. And this is perfect for providing that service-centric view of your monitoring information. So on the right there, you see one of our example maps where we're monitoring different services, such as our email or our web shop or our ERP system or the print services. And we have a single pane of glass view showing us the health of all of those services using these traffic light widgets. Now, behind these traffic light widgets, we're using a very special type of sensor called our business process sensor. This is an aggregate sensor that actually monitors the state of other objects within PRTG. So using the business process sensor, we can pull the status of multiple components that form part of a business service, and we can present this as a single visualization showing us the health of that service. Now, in addition to PRTG, we have extended to include a number of extensions. One of those is SLA Reporter, and SLA Reporter, as the name suggests, is used to generate SLA reports against particular services or SLAs within your environment. Now, the great thing about SLA Reporter is that you can take these business process sensors and monitor the SLA against the service rather than the uptime of individual components that form part of that service. So do we have, well, sorry, in the example of email, we may just want to know whether email is up or down. So in this case, we would create a business process sensor that would monitor several components of our email infrastructure. And then if any one of those components were to go down, impacting the email service, this would be reflected via the business process sensor. And then we could build an SLA in SLA Reporter around this business process sensor and identify any downtime. Now, this is a nice quote from one of our customers, Riverford Organic Farmers, that are responsible for delivering 50,000 vegetable boxes a week across the UK. And they confirmed to us that simply putting in PRTG has helped them to avoid around £10,000 worth of missed deliveries by monitoring those key services. So just to recap then, if we wish to look at monitoring from a service-orientated approach in the future, the first stage is to map your IT infrastructure via value streams for particular services or products. Now, rather than looking at your infrastructure from a siloed perspective, so looking at your IT, OT, IoT, and IIoT space as individual silos, we should just monitor everything. And within PRTG, we can build a service-orientated overview using maps to present all of that data in a single pane of glass. And now I will pass back to Jimena for some feedback.
Yes, thank you, Stephen. So I'd like to share some exciting things with you. First, since your feedback is extremely important to us, we want to say thank you by giving away $25 Amazon gift cards to 5 lucky winners. How can you enter? Well, simply scan the QR code that you're seeing now on your screen, and you can also decide to visit the URL at the bottom of the slide. This will take you to G2's review site where you can write a review about Paessler PRTG. Afterward, take a screenshot of your review and send it to me at jimena.robles@paessler.com no later than April 30th for a chance to win. And it's as simple as that. And then we have a few minutes left just to answer some of your questions. So I will start reading some, and Stephen and David, or David, you can decide to which ones you want to answer. First one, do we need to have OPC UA set up on the PLCs or the SCADA in order to connect?
I will take that one. So yes, the OPC UA architecture will need you to have a server already connected to some of your devices. So as long as you are following the OPC notation, you will be able to use our OPC UA custom sensors for you to query information out of those devices into PRTG. It's very similar. If you make the comparison, it's very similar for like you having SNMP on both your device and also PRTG. So that both devices can communicate to one another. It's very, very similar. But yeah, you need to have it in place. If you are unaware of whether you are using OPC UA already, you can always maybe go and ask the people on the industrial controls, and they probably will know.
Thank you, David. Number 2, we have radius sensor supports only PAP authentication. Is there any plan to support also PEAP authentication? I think you're muted, Stephen.
Thank you for that. Yes, I'll take that one. It's not currently on the roadmap, but we can certainly take that feedback and pass it on to our product management team and developers for consideration in a future release.
Thank you. Okay, we have time for only one more question. Can you please repeat the names of the sensors that aggregate the results from different sensors?
Yes, so that would be the business process sensor. So the business process sensor works by monitoring multiple objects in PRTG. So this could be groups, devices, or sensors to collect the state from those objects. And then based on thresholds, you will get an output from that sensor. We have another aggregate sensor, which is the sensor factory sensor, and this can be used to combine channels from multiple sensors and also to do calculations on the values that are returned via those channels.
Perfect. So time is up now. And thank you again for your participation. And we hope you enjoyed learning about the OSI model and all the possibilities for service-oriented monitoring. And remember that you can always go to our website and sign up for any of our upcoming webinars. Thank you, everyone.